The next major topic I want to talk about is the TCP/IP model. However, before we talk about the TCP/IP model, we need to talk about the TCP/IP suite. The TCP/IP suite is a group of protocols that have been designed to work together to send data across a network. The TCP/IP protocol suite is named after the two major protocols in the suite. The first major protocol of the TCP/IP suite is the TCP protocol. TCP stands for Transport Control Protocol. The other major protocol in the TCP/IP protocol suite is the IP protocol, and it stands for Internet Protocol. Aside from these two main protocols, the TCP/IP protocol suite also contains a large number of additional protocols that are used to carry out many different functions on the network. One thing to keep in mind about the TCP/IP protocol suite is that it is an open protocol suite. What this means is the TCP/IP protocol suite is available to be freely used by anybody, anywhere, without having to pay a company or pay a licensing fee or something like that. Being an open protocol also means that new protocols can be freely developed as new technologies are developed to allow those new technologies to access the larger network as well. The TCP/IP protocol suite is the only protocol suite that is used by the internet. Additionally, pretty much all existing networks also will use the TCP/IP protocol as their main transmission protocol. Now we've talked a little bit about the TCP/IP protocol suite. Let's go ahead and look at the TCP/IP model. Essentially, the TCP/IP model is a reduced version of the OSI model. However, a significant difference between the OSI model and the TCP/IP model is that the OSI model was never based around a real protocol suite, whereas the TCP/IP model is based around the actual existing and commonly used TCP/IP protocol suite. What this means is the different protocols in the TCP/IP protocol suite will match up perfectly with the different layers of the TCP/IP model. This will aid in more clearly understanding the roles of the different protocols that are part of the TCP/IP suite. The TCP/IP model has 4 distinct layers. The top layer, or the fourth layer if we were talking about the OSI model, would be the application layer. The layer below that is a transport layer. The layer before that is the internet layer. Below the internet layer, we have the network access or network interface layer. This bottom layer may also go by some other names like link layer. All the protocols in the TCP/IP protocol suite are actually located on the top 3 layers of the TCP/IP model. The protocols that are located on the bottom layer, the network interface or the network access or even the link layer, are not part of the TCP/IP protocol suite, but instead are technology-specific protocols that are used for specific communication technologies such as Ethernet, 802.11, 802.15, frame relay, ATM, things of that nature. Each one of the layers of the TCP/IP model correspond to one or more layers in the more traditional OSI model that we looked at previously. This diagram gives us a view of what the TCP/IP model looks like. As you can see, at the top, or layer 4, we have application layer. Then we have transport layer, internet layer, and then finally network interface layer, also called network access layer, or even occasionally link layer. This diagram here shows some of the more common TCP/IP protocols that you may have heard of, and the layer of the TCP/IP model that those protocols match up to. Now we've looked at the TCP/IP model generally. Let's go ahead and look at each particular layer of the TCP/IP model like we did with the OSI model. The first layer we're going to look at is the TCP/IP application layer. The TCP/IP application layer defines the protocols, services, and processes that allow both programs and users to interface with the network. The application layer also defines how programs interface with the transport layer services below the application layer that enable it to use the network. There are a number of application layer protocols that are commonly used and that you may have heard of. We'll look at a few of those. First, we have the HTTP. HTTP is Hypertext Transport Protocol and is used to transport web pages across the internet. Next, we have Telnet, which is a remote access protocol that allows you to remotely access other computers using a command line. The main drawback of Telnet is that it doesn't send the passwords in an encrypted format, it sends the passwords in clear text. Another common application layer protocol is FTP, or File Transfer Protocol. This is a protocol that is used to move large files across a network. Another protocol is the TFTP protocol, which is the Trivial File Transfer Protocol. This protocol basically does the same thing as the FTP protocol. The main difference is that the FTP protocol has error checking and acknowledgments built into it that the TFTP protocol does not have. Next, we have the Simple Network Management Protocol. This is a protocol that allows network administrators to remotely manage computers on a network. Next is the DNS protocol, or Domain Name Services Protocol. This protocol is used to take the more elaborate URLs that humans are used to using and translating them or converting them into the IP addresses or the IPv6 addresses that the computers are more used to using. Next, we have SMTP, or Simple Mail Transport Protocol. This protocol is used by email to move the messages between email servers. Finally, we have the X Windows Protocol. This is a protocol that is used by various Unix and Linux operating systems to generate the graphical user interfaces that are common to those particular operating systems. There are many other protocols, but these are the ones we'll just deal with right now. The next layer of the TCP/IP model we want to look at is the TCP/IP transport layer. The TCP/IP transport layer provides communication session management between the host computers that are talking to each other. Also, the transport layer protocol defines the level of service and the status of connections used when transporting data between the two host computers. There are several protocols that are commonly used on this layer that you may have heard of. The first is TCP protocol. The TCP protocol is one of the named protocols of the TCP/IP protocol suite and stands for Transmission Control Protocol. Another protocol is the UDP protocol. UDP stands for User Datagram Protocol, and this protocol works very similarly to TCP. The difference is, while TCP has acknowledgments and error correction, things like that it does, UDP does not. Finally, we have RTP, which is the real-time protocol. Real-time protocol is one of the protocols used by Voice over IP as well as some other services that allow real-time communications between users. The next layer we want to look at is the internet layer of the TCP/IP model. The internet layer is responsible for taking the data and converting it into an IP datagram called a packet. Once the internet layer has created a packet, it then creates a header for that packet that contains the source and destination information needed to move that packet through the network. After the internet layer has the source and destination information, it then uses that information to actually move the packet across the network. In essence, you can say the internet layer's job is to perform routing of IP packets across the network. Several common internet layer protocols that you might have heard of are as follows. First, we have the IP protocol, or the Internet Protocol. This is one of the protocols that are the named protocols of the TCP/IP protocol suite. And the purpose of the IP protocol is to find the best route and move packets following that route across the network. We also have the ICMP protocol. ICMP stands for Internet Control Message Protocol. And this protocol is used to send out control messages across the internet that IP then uses to find routes and things like that. Also, ICMP is used by the ping tool and the traceroute tool as well. In the case of the ping tool, ICMP is used to get replies back from other nodes to verify that the nodes are up. In the case of the traceroute tool, ICMP is used to get a reply back from each node along the route to the destination and then displays each one of those node locations so you can then trace out the entire path the packet needs to take to its destination. Another common protocol on the internet layer is the ARP protocol. ARP stands for Address Resolution Protocol, and this protocol is used by IP protocol to take a logical address or an IP address and find out what the physical or the MAC address that matches that IP address is if it doesn't already know it. There's also the RARP protocol, which is basically the exact opposite of the ARP. RARP stands for Reverse Address Resolution Protocol, and this protocol is used when IP has the physical address but does not know the IP address. It'll then use the RARP protocol to determine what the logical address is that matches the physical address it already knows. The final layer of the TCP/IP model is the network interface layer. The network interface layer is also sometimes called the network access layer, and occasionally you may even hear it referred to as the link layer. The network interface layer specifies how data is physically sent through a network. But one of the ways it does this is by specifying how bits are electronically signaled by hardware in the case of copper media, or in the case of fiber optic media, it specifies how bits are photonically signaled by the hardware. The network interface layer also defines how hardware devices interface with network mediums. Some of the network mediums you may run across are coaxial cable, optical cables, and twisted pair cables. In the LAN environment, the twisted pair cable is definitely the most common one you will see. There are a number of standards that are defined by the network interface layer. One such standard is the Ethernet layer, which is the primary standard that is used to send data across a LAN environment. We also have token ring standard, which is an older standard that came out around the same time as Ethernet, but has fallen out of use since then. We also have the FDDI standard, which is a fiber optic standard used for WAN environments mostly. Then we have the much older X.25 standard, which was one of the first standards used for a large wide area network. Additionally, there's the frame relay standard, which is still used sometimes in a wide area network. There's also the RS-232 standard, which basically defines serial interfaces and even the COM ports that you use on a regular computer. Finally, we also have the V.35 standard, which is a standard used in relation to dial-up networking. I spent a lot of time in the last few videos talking about the TCP/IP model versus the OSI model. Well, now I want to go ahead and put the two models side by side, and we can take a look and see how they stack up against each other. In this graphic, on the right-hand side, we have the TCP/IP model and its 4 layers. And on the left-hand side, we have the OSI model and its 7 layers. I've lined up the layers on the TCP/IP model to match the function that they cover compared to the OSI model. When we do this, we see that the top layer of both models is called the application layer. However, in the case of the TCP/IP model, the application layer not only does the job of the application layer, but also the presentation layer and a significant portion of the session layer of the OSI model. The second layer of the TCP/IP model is the transport layer. This is the same name as the transport layer in the OSI model. However, significantly in the TCP/IP model, the transport layer does the function of the transport layer in the OSI model, as well as some of the functions of the session layer. Next in the TCP/IP model, we have the internet layer. The internet layer actually covers the job of the network layer in the OSI model, as well as the upper portion of the daylink layer in the OSI model. Finally, the last layer of the TCP/IP model is the network interface layer. When we compare the network interface layer to the physical layer of the OSI model, we see that the network interface layer does the job of the physical layer and the lower half of the daylink layer of the OSI model.